how about a square root 1? Can we figure out whether this is concave up or concave in? If you go over and you help the one guy. Alright, so we got to find the second derivative, right, if we want concavity. So this would probably be easier to think of this as x times 4 minus x squared to the half. We just got to go about doing the product. The derivative of x is 1. Multiply it by 4 minus x squared to the half. Add to that the derivative of 4 minus x squared to the half, which would be 1 half 4 minus x squared to the negative 1 half times negative 2x. That's the derivative of this, and I can multiply that by x. So you already tell this one looks like it's going to get messy for the second derivative.
Yeah. Sorry.
But we're not going to let it intimidate us. This is in North Carolina. We still live in Arizona.
We are American.
Not Americans. So let's see. If we want to go about factoring this thing, well, first off, this 1 half and this 2 can cancel. We can take out a 4 minus x squared to the lowest power again. So we can take it out to the negative 1 half. So what would be left in this first term that we got? 4 minus x squared to the first. Right? Because it's like we're dividing by this. When you divide, you subtract the exponents. A half minus a negative half is 1. Then over here we got this minus. We took this out. We're left with x times x. We're left with x squared. Oh, look at that. So no need to, for our fretting earlier, we were all worried about this. This now, we can leave it this way if we want. 4 minus x squared to the negative 1 half. And then up here we get 4 minus 2x squared. Alright, so Terry would do it like this. He doesn't like the quotient rule. We can bring this down, make it a fraction, do the quotient rule, or leave it like this and do the product. Or why don't we, since what we learned those last two examples right now, let's see if we can use our calculator to figure out these intervals. Alright, I'm going to come in here and I'm going to graph this. So I'm going to do 4 minus x squared raised to the negative half. And then multiply that by 4 minus 2x squared. So the standard graph. Let's see if I can see it. That's interesting. I wonder why they graph, I don't see anything. Like beyond negative 2. That's the domain of this thing is only negative 2 to 2, isn't it? All right, anything less than negative 2, this becomes a square root of a negative number. It's not a real number. So that's nice. Now when I look at this graph, there's only one maximum, huh? If I do second calc, it looks like it's 0, but a second calc maximum. And I'll move to the left of the highest point, hit enter, move to the right, hit enter, enter again. Again, there's that little flaw of the calculator, 1.15141e to the negative 6. It's really 0. So it has a maximum at 0. So the graph's going up. The graph's going up from negative 2 to 0. So would that thing be concave up or concave down? The graph is going up, its first derivative is positive. So the second derivative is the derivative of the first derivative, so that means the second derivative is positive. So it means this thing is concave up.
Even though it doesn't, that's not find the little negative 2.
Right, that's why I said it started at negative 2.
Yeah. Well, I'm saying.
Oh, so you're saying, should we use the parentheses at negative 2?
Well, no, I'm saying, like, since it, well, we probably should, yeah, but, like, since it doesn't, it's not like continuous, it doesn't, like, make a curve like this. It's
Well, negative 2,
then it's just 4 minus 4 squared root of 0. That's okay.
Yeah.
Yeah, but at that point, it's not really concave upper, you know, I think I'm gonna go with a bracket, or a parentheses, and we'll double check.
I'm just a little confused with the graph that's cut off that way.
Yeah.
So,
Next.
Let's just say here, I'm gonna take a picture of this. We'll do it, we're gonna work it out too. Just look at this. Okay, this was y prime. What's the graph of y prime? All right, maybe if we even go back to the graph of the original function. Right, that's x times the square root of 4 minus x squared. See how it looks like it's concave up till it gets here, then it's concave down. That matches. Wow, we could have even done that without the first derivative. Yeah, if I would have changed my window to go -2 to 2 and then do zoom fit, that would have been even nicer. All right, so let's finish this off if I can here, and then we'll take our break. What if we had to go about the second derivative? And we just use the product rule with the chain rule. Derivative 4 minus x squared to the negative half would be -1/2 times 4 minus x squared to the negative 3/2. So we'd have to multiply that by the derivative 4 minus x squared, which is -2x. Then multiply that by this, 4 minus 2x squared. Then we add to that the derivative of 4 minus 2x squared, which is -4x, times this 4 minus x squared to the negative half. So let's see here. Cancel some things out. Negative makes a positive. Half cancels the 2. Nothing over here. We've got 4 minus x squared raised to a power in both terms. So we can take it out to the lowest power, to the negative 3/2. Well, it's 4 minus 2x squared.
Oh.
Right. Because I was looking at that 2 at first. That's a little different. Because the 2 let's see, there's an x here, right? And an x here, so let's take out an x as well. So now we took this out, we took out an x, so we're just left with 4 minus 2x squared. Then over here, that's going to make it negative. We took out the x, so we still got the 4. What's left here if we take out a 4 minus x squared from -3/2?
so that's squared. 4 minus x squared.
4 minus x squared squared. So you're basically thinking of this, if we divided this by 4 minus x squared to the -3/2, you're saying -1/2 minus a -3/2. I think that's, -1/2 plus 3/2 would be 2/2.
Oh, okay, so it's just one.
So it's just 1. So let's see here. Second derivative. I'm going to go ahead and bring this down here. We have 4 minus x squared to the 3/2. So I have this x up here. Then this would be -16 plus 4x squared. 4x squared minus 2x squared would be 2x squared. Then we got 4 minus 16 would be -12. So I can take a 2 out of that. 2x times x squared minus 6. Over 4 minus x squared to the 3/2. So the things that would make this 0 are 0 and plus or minus square root of 6. Right, we said that equals 0. And the denominator would be plus or minus 2. This is bigger than 2, right? It's outside our range. Square root of 6 is bigger than square root of 4, which is 2. So this This one's outside our range. This is the endpoints of our domain, or outside our domain. This is the endpoints of the domain, so that's the only possible point of inflection. Right? If we set up our interval, went from -2, well, at -2, this would be undefined, so it's not concave up or concave down, so we do want to use parentheses. So -2 to 0, 0 to 2. Check the second derivative. Say at -1, this would be negative, this would be negative, and that's going to be positive. Negative times a negative makes a positive. Did that match what we said? Concave up from -2 to 0. If we put 1 in there, we get positive times a negative times a positive would be a negative. This is one where looking at the graph of the first derivative, or even the graph of the original function would have been helpful. But not something we could